Newton's first law of motion states that an object in motion stays in motion and an object at rest stays at rest. To show this, we're going to put this cup on top of this car and it's going to stay in the same place. Another example of Newton's first law of motion is this basketball. It's rested, so it's going to stay at a rested position until acted on by an outside force. The ball was in motion, so it stayed in motion until acted upon by an outside force, my foot.
Alright, for our second example of Newton's first law, we are going to be demonstrating an object in motion stays in motion unless acted on by an outside force. We're going to have this car go forward and then suddenly slam on its brakes, and this seatbelt is going to stop me from continuing moving forward through the windshield. And you don't have to go like as fast as you did before, just make sure you get up to like 20 and then just slam on your brakes. You can go a little faster. That's pretty exciting.
Close one. Brakes work.
Newton's second law of motion states that the acceleration of an object is dependent upon two variables: the net force enacted on the object and the mass of the object. To demonstrate this, we're going to have Ethan hit a basketball and a golf ball with the same amount of force and see which one goes further. This is how far the golf ball went. This is how far the basketball went.
Okay, so this is another example of Newton's second law of motion. I have the mass of just one single person riding this bicycle, so I'm able to go faster than I would be if there were more than one person on this bicycle.
Ethan can't go as fast on his bike when there's more than one person on it. For our second example of Newton's second law, Ethan's going to push this car, and he's going to push it into the lawn chair. Obviously the car weighs more than the lawn chair, so we're going to see which one he can push more easily. I'm going to stay in the car to keep it on. He's moving it. Maybe you can tell. Now he's going to push this chair. Not bad, no? Newton's third law of motion states that for every action, there is an equal and opposite reaction. Our first example is me sitting in this chair. I'm exerting a force on this chair, and the chair is exerting a force back on me. Without this, I would just fall to the ground. Our second example, Ethan is going to try and push this house. I think I saw it move a little. Another example of Newton's third law of motion is bouncing a basketball on the ground. The force exerted by the ball on the ground is exerted from the ground back to the ball, causing the ball to come back to me, like so.